Okay, we are live. Okay, so today,
like and subscribe.
test 5 review. Okay, number 1. And I'm going to do a lot of this on a separate sheet of paper, so it's up to you. You guys can or can't, you can put it on your sheet, but I'm going to do it here. Number 1, e to the x equals 10, right? And again, I have, thank you, I have the transition from log form to exponential form on the board. And all we're going to do is go from exponential to log on this one. So we're going to rewrite this as log base e of 10 equals x. However, if it's log base e, we're going to rewrite as ln of 10 equals x. Now don't evaluate it. Don't push any buttons. That's the answer. I just want you to show me you can move from one form to the other. Okay? Yeah, Seth?
We just wrote in log forms that Alan would do so.
I will take half off. Because you should, yeah.
Yeah.
Yep. Number 2, we're going to go and just do the opposite. Number 2, we're going to change it from log form to exponential. I've got log base 8 of 16 equals x. So we're going to change it from log to exponential. I'm simply going to go 8 to the x power equals 16. 8 to the x power equals 16. Now that I'm going to leave like that. There's no way to change that. Don't try and evaluate it. Don't use a calculator to get an answer. This is all I want. It's just that you can show me you can move from one form to the other. Okay? 3. Rewrite this as a single log. So I've got log. Yeah, I sure can, Julia. Log base 4 of 16 plus log base 4 of 10 minus log base 4 of 20. Okay, so it says plus, I bring it together as times. If I see subtract, I bring it together as a divide, so I'm going to rewrite it as a single log. Single log, so log base 4, single log of, well, of what? Well, we'll have a 16 times a 10 divided by 20. And I'm going to simplify that a little bit because I can, right? I'll rewrite that as log base 4 of 160 divided by 20. Right? Because I can do that. That's easy. And then may as well make that 8, right? 20 goes into 168 times. So I'll rewrite as log base 4 of 8. Boom. Okay, how's that? Alright. 4. I'm going to use my graph paper. I'm going to try to do a really accurate job. So, yeah, go ahead, grab a piece of paper. So number 4, I'm going to graph. So 4, I've got to graph y equals log base 2 of x and its inverse. Okay, and its inverse. So its inverse is the exponential. So to do it, and to do a really good job, its inverse is the y equals 2 to the x power. Okay, that's its inverse because you're going to change it from log form to exponential form. I'm going to show you how I got the inverse, okay?
Equals 0?
No.
Oh, okay.
But let me keep going. So to show the inverse real quickly, if I switch x and y for the inverse, right? So I switch x and y and have a x equals log base 2 of y, and then rewrite it from log form to exponential form, you will get y equals 2 to the x. So here's my inverse, and here's my log, okay? So for us, it's probably going to be easier to graph the exponential first instead of graphing the log. Because graphing the log is a little bit harder. I mean, you can try it on your calculator. You can try it on your calculator, but it's a little bit crazy. But one way you could do is like you can go log, to graph it. I can go my math, I can go my log base 2 of x, and I could graph it, but it's just, that's kind of a hard way to do it, okay? It shows the log there, but for me it's easier to graph the exponential first. What's that? Autumn. Okay.
I just wanted to be able to see the word.
Right. So I'm going to graph the exponential first. So I'll graph this one first. And then graphing the log will be easy, okay? So let me graph the inverse first, because I really need this to be accurate. I need some good points in here. So if I graph my exponential first, then I'm going to plug in some points. So I plug in 0. Anything 0 power, if I plug in 0, anything 0 power is 1. Okay. If I plug in 1, anything 2 to the 1 power is 2. If I plug in 2, 2 to the 2 power is 4. I'm going to do one more before because I'll be off my paper. If I plug in 3, 2 to the 3rd power is 2 times 2 times 2 is 8. Okay. So if I graph this, I should get a point here, a point here, a point here, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that looks like my exponential, doesn't it? I can also have negatives. I can also throw in some negatives. If I do -1, well, 2 to the -1 power is 1/2. It really is.
It is 1/2.
Yeah, that's exactly right. If I do -2, I get 2 to the -2 power is really 1/4. And then I could put those in there and there. Okay, so that looks like an exponential. We've graphed those before, right? I'm going to connect the dots. Yeah, Julia? I'm going to connect the dots. Remember, it does not touch the x-axis. It's like that half of a half, half of a half of a half, half of a half of a half. It never touches it. It gets smaller and smaller and smaller, but never touches, okay? Oh, that's a beautiful picture of it. Like that. Now, its inverse is the log. So to do the log, the easiest way to do the inverse is to take my points. We'll switch them, right? Just switch them. So I'm going to have a point at 1, 0, because I just switched my point. I'm going to have a point at 2, 1. I'm going to have a point at 4, 2, at 8, 3, okay? And I'll even switch my negatives, so I'll switch these around to become a 1/2 -1 and a 1/4 -2. Okay, now I can graph these pretty easily. So I'll have a 1, 0, a 2, 1, a 4, 2, an 8, 4, 5, 6, 7, 8, 3. A 1/2, -1, and a 1/4, and a -2. And the log graph looks like this. There's its inverse. Now I'm going to have some asymptotes. I'd like you to put the asymptotes in. I'll have an asymptote here at y equals 0. And I'll have an asymptote here at x equals 0. There's my asymptotes. So far, so good? Okay, am I going too fast? Oh, wait, no, you're good. Okay. Turn the page. Go on to the next one. Okay. All right, number 5. And I'll do number 5 on this sheet because it's here. So, number 5. Okay, here is find the equation of g of x. Okay, so first of all, we got to know that they're talking about a log graph, right? Now, if I go and shift and look at what I just graphed, okay? Take a look. Can I see? I want to see these both together, okay? Let's see if I can compare these, okay? So in red, here's my log graph, right? So I went from the red graph to this graph. What do you think happened? From the red graph to this graph, what do you think happened from here to here? Looks like it's upside down, doesn't it? Can you see that? Well, let me go ahead and draw the original graph. The original log graph looks like this. We just did it.
Do you move it up?
Yeah, just the original log graph, the parent function of a log graph looks like this, okay? That's a regular log x, okay? So what it looks to me is if I took my log graph, my original, like parent function, and flipped it upside down. So that means what happened is the y values all the y values here became negative here, and all the y values here became positive. So my y values changed. So what I did is I went a negative y equals log of x. All my y's became negative, right? Shift it over. My y values you can see. And so if I want to solve for y, just bring it over, and I'm going to get a y equals a negative log of x. And that's going to be the equation. You can see it's upside down. So my transformation is a negative log. It's a reflection of the x-axis, okay? All right, here comes the easy stuff. You guys ready for the easy stuff? Should be. We've been practicing this a bunch. Okay, let's solve for x, huh? Take a look at number 6, okay? And we'll be done with this pretty soon. It's not that bad. 6. I've got 10 to the x equals 11,345. Well, I'm going to have to use a log. Anytime I have an exponent that's next, I've got to do logarithms, right? So let's change it. Log base 10 of 11,345 equals x. Log base 10 is my calculator log, right? So I can just go straight to just using my calculator. I'll do that. It's going to be pretty simple if I go log of 11,345. I can answer about 4.05 approximately. X is approximately equal to 4.05 blah 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 blah. Okay, pretty simple. Okay, 7 again. I'm going to just do 7 on a separate sheet of paper. E to the x equals negative 8. I think this one's going to be an error. Before I even do it,
It is.
I'm pretty sure this is going to be an error because they can't equal negative. So, but if I do that, if I go log base e of negative 8 equals x, so I change it to log form. That's a natural log. Remember, that's ln. So if I go ln of negative 8 equals x, and logs can't be negative, but you can try it in your calculator, but you should get a domain error. You should, right? Can I show you why? Not that anybody cares, but I'm going to say no solution. Check out the graph, just because I like you to know why. But look at this graph. Here's a log graph, right? You guys look at this log graph. Are there any answers over here in the negatives? No, they don't exist, do they? Okay. All right. Flip the page. Do number 8. Easy so far? Yeah. Should be. I think you guys, logs are not that hard. Usually logarithms are usually an A test for most kids. Log base 3 of x equals 5. Okay, I'm just going to change this to exponential form. So we're going to go, okay, 3 to the 5th power, right? 3 to the 5th power equals x. 243? I don't know. Let's check it out. 2, 3, 5 power. Yeah, 243. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243 is the value of x, okay? That's not bad. You can do that. All right. Number 9. Okay. Okay. 6 times 3 to the x equals 72. Okay. Do not multiply. That is not an 18. Don't do that. Because you have to do your exponents first and you can't. Does that make sense? So let's just divide by 6. Divide by 6, divide by 6. 3 to the x equals, what's that, 12, I think?
Yeah.
And let's change it from there to log form. So we're going to go, okay, I can do that. Log base 3 of 12 equals x. And we'll just use our calculator. Okay, math. We'll go find our log button. Log base of 3 of 12, right? So I just use my log base button, right? Log base 3 of 12, and I get an answer of 2.26. Okay, there you go. All right, 10. 2 ways to do 10. I'm going to do it the easy way, really. You could do the log of it. You could. If you wanted to change the log form, you can. Just real quickly, if you wanted to write, and I'll do it on the board, there are 2 ways. I want you to know whatever's easiest for you, okay? You could go straight to, oh gosh, log base 5 of 125. equals 3x minus 9. That'll work. That'll work. Okay, if you want to do that, and then of course that's going to be 3, and then you can solve for x. But I'm going to do it a slightly different way. I'm going to change it because I can make this into a 5. I can make that into a 5, and then it's easier for me. And again, I don't care which way you use, as long as you get the right answer. Okay. So I'm going to change that to a 5 to the third power because I know that 5 times 5 is 25 times 5 is 125. So if I keep them and make them the same base, we learned a rule that allows us to cancel that to that, and then we're left with just simply 3x minus 9 equals 3. Or just solve for x. We'll go plus 9, 3 to the x equals 12. Divide by 3, x is 4. Now, these answers can be negative. It's not, but they can be negative because they're exponents. They're not logs. Exponents can be negative. No big deal, but logs can't, okay? How am I doing? Okay, shall we do 11? Let's do 11. You guys doing a great job of listening quietly. Appreciate that. Okay, number 11. Got, okay, log base 4 of 4x minus 5 equals 2. Okay, this one's not too bad because we're just going to change it to exponential form. Okay, we're going to go 4 to the 2 power, right? 4 to the 2 power. 4 to the 2 power equals 4x minus 5. Okay. 16, right? Equals 4x minus 5, right? Plus 5 plus 5 plus 5. 21 equals 4x. Divide by 4, goes in 5 and 1/4 or 5.25, right? 5.25? Yeah. Yeah, me too. Okay, how am I doing? Am I going slowly enough? You bet, Julia. I'm not doing this for me, I'm doing this for you, right? How's that? All right, I'm going to write down number 12 while I'm waiting for you, Julia, okay? You give me thumbs up when you're ready. You good? Okay, so it's ln of 2x plus 9 and ln of 5x minus 6. So what I know, we've got this rule. If you've got log of something equals log of something, you can just cancel out the logs. It makes sense, doesn't it? So then I can go straight to a 2x plus 9 equals a 5x minus 6. Okay. I need to solve. Minus 2x minus 2x. And I've got a 9 equals a 3x minus 6, right? Plus 6 plus 6. I've got a 15 equals a 3x. Divide by 3, and x is 5. I think that answer is okay. Yeah, if I check that answer, I'm not going to have any negatives, so I'm good. X equals 5 works for me. Okay, 13. I'll squeeze 13 in over here. And I might need another piece of paper. ln of x equals 0.8. Okay? So, ln is base e, right? Invisible base e. So we're going to go e to the 0.8 to the 0.8 equals x. So we just change it from log form into exponential form, and I'm just going to use my calculator. What is e to the?
Error.
Is it really? No, it should work. I got about 2.22.
But your E is not negative.
Let me see what you got. What you type it in. Yeah, you got it. Good there. So you got it. Good. Okay. How am I doing? Good? Okay. All right. Turn the page for me, right? You got it?
Yeah.
Okay, good. Turn the page for me. I'll hang on to that. Now, let's see what we got. Last but not least, number 14. Number 14 should be pretty easy. 14 should be easy. I don't think this test will be hard for anybody. I really don't. 14. This was number 4. Okay, 14, first thing I'm going to do on 14 is make a scatter plot, okay? So, it looks like it's an exponential to me. I can do that, so. Okay. I'm going to put down years down here. We'll put years. I'll go 1, 2, 3, 4, 5. I think we did this problem, didn't we? 6. We did this problem earlier. Makes it easy, okay? Sales, probably have to go by tens. Sales, and then I'm going to go probably 10. The only way it's going to fit, 20, 30, 40, 50, 60, 70, 80. I got to go up to 100, definitely 80, 90, and 100. Okay, it'll fit if I go by tens that way, right? Okay, now let's see a scatter plot. Okay, this is going to be easy. I've got a 1 and 12. Right about there. 2 and 16. Right about there. 3 and 25. Right about there. 4 and 36. Looks like it's starting to curve. I expected it to. 550. Yeah, it's starting to curve. 6 and 67. 7 and 96. Right about there. Okay, definitely looks like it's curving. Looks like it's going to be probably exponential to me, right? All right, Jay, have a good day at college. We'll see you. Okay, looks like exponential, right? So what I'm going to do is I'm going to use my calculator, right? We're going to go to stat. And I'm going to put all this data in, right? So I'm going to go stat. We're going to go to edit, right? So I'm going to go clear, go stat, edit. Hey, they're still in from the last time I did this problem. It's the exact same problem, so I enter all my data, right?
Oh.
Isn't that nice? Got lucky, didn't I? So I enter all my data. Okay, you guys want to take some time to enter all your data in, or do you just want to follow along with me? It's okay, either way.
Yeah, I'll just follow.
Because you guys, you know how to do this, right? You guys agree? Everybody knows how to do this? So then I'll go, actually enter my data, enter my data. I just did that. And then I'm going to go to stat and calculate, okay? So I'm going to go stat again, calculate. And I'm looking for my exponential regression, okay? So right there, exponential regression, that's the one I want right there. It's exponential regression, push enter. Go all the way down to calculate. Oh, mismatch. Doggone, is this the one that doesn't work? I may have to do it all over again. So, anybody else? Did anybody put them in? Can I borrow yours, partner? Probably, of course it is. Well, double check. Okay, should we double check? Stat, edit. Yeah, those look right, Parker. Okay, stat, calculate. I've got one calculator that's not doing this for some reason. I don't know quite why. Exponential regression. Enter. There we go. So if you look at it, A is 8.4, so I'll put that right there. B is 1.42, maybe I'll put right there. So I'm going to go, okay, y equals 8.4, maybe 5.7 for accuracy, and a 1.419 for accuracy to the x power, okay? With exponentials, accuracy actually makes a big difference. It really does. The more decimals you can get down, the more accurate it's going to be. Okay, so there's my equation. And that has to do with sales or trampolines per year. So I might just go T for trampolines, 8 point. You don't have to do this, but for me it helps me with my problem if I change the words, okay? So I just change the letters to trampolines for T and this T for years, okay? Now, C. What would the sales be after 10 years? So we're going to let, for 10 years, we're going to let T equal 10. So I'm going to go T, trampolines equals 0.8457, 1.419 times 10 to the 10 power, right? And I'm just going to use my calculator. That's all I'm going to do is just go through and do that. So Seth, I'll get, or Parker, I'll give you back your calculator. Thank you. You're good, man. Thank you for helping me out. Okay, so I'm just going to use my calculator at this point. So I'm like, all right, I can do that. I'm gonna go, okay, on 8 point, can you guys see that? Nope, you can't, but you will in a second, okay. 8.475 parentheses 1.419 to the power of 10, right? Power of 10, because I'm looking for the 10th year, having trampolines. So almost about 280 trampolines, about 280 because I'll round it up. Trampolinos, right? How am I doing? Now the next one's going to take some work, but we can do it. Okay, now we're going to sell 500 trampolines. Wow, that'd be a landmark for us. So we set it equal to 500. So 500 equals, and we're going to go my 8.457 times a 1.419 to the t power. Okay, now here's the key, and I'm going to say it. If you want to solve for x, if you're going to want to get this out of here, you're going to need a logarithm. The only way you can get this down here is to change it to a logarithm. Does that make sense? So we have to do a log. But first, let's get rid of this number, okay? We're going to need to do a logarithm, but first let's divide by 8.457. 8.457. So we're going to take my 500. Oh man, 500, 500 divided by 8.457, and I get an answer about 59.12, so I got a 59.122 equals my 1.419 to the t power. Okay, now, I'm going to have to do my work over here. I'll scoot it up over here, okay, so you guys can see it. All right, how am I doing? Am I going too fast? Now, let's log it. Let's change it to a logarithm, okay? So it's going to be log base 1.419 of my 59.122 is equal to my t, right? And I think my calculator can do any base, so I'm just going to go and do my math. Pretty sure my calc can do any base, so just go to my math. Base. Let's see if it does a 1.419. I hope so. If not, we'll have to do it the other way, right? But I think it will. I have a 1.419 of a 59 point, just use my answer button, blah, blah, blah. And it does it. 11.65 or 11.6. Huh? Yeah. Yeah. How's that? Can you see it, Autumn? Let me write the answer down.
I kind of lost it.
Okay. Let me help you type that again. Okay, I'm going to go ahead and stop my